since you guys have written these down, I'm just going to briefly clarify some points on them. If you have a question, make sure you ask. Okay, but so we're going to define these following words: polynomial in one variable. Okay, that basically just means that you're going to have something like x to the fourth minus 6x to the third plus 5x squared plus x minus 2. Okay, the only variable there is x. There's not an x and a y variable. Okay, that's what we mean by a polynomial in one variable. Okay, a polynomial in two variables would have an x, so it might say something like x to the fourth y cubed minus 6x squared cubed y to the first power, or something like that. Okay, so this is just a polynomial in one variable. There's only one variable, and it's x. Now, the degree of a polynomial, you find the highest degree. In this case, it is 4, right? So this is a fourth degree polynomial. Okay. Okay, so that's a fourth degree polynomial. The leading coefficient is the number in front of, let's say that this was 3. 3x to the fourth, okay? And my leading coefficient would be 3 because it's the coefficient of the highest degree term. Okay, a polynomial function. Well, what's the difference between a polynomial function and a polynomial in one variable? The only difference is all of a sudden you put a y equals or an f of x equals in front of it, right? So it's, I have the same polynomial up here expression. See, up to the top right here, this was just an expression up here. Down here, all of a sudden we put a y equals on it, it becomes a function or an equation, okay? So we're talking about a polynomial function. Now, some of the problems on your assignment are going to talk about just the expression. Some are going to talk about the function. The only difference is a function has a y equals or an f of x equals on it. Got it? Okay, zeros of a function are the x-intercepts. Okay, it is where they cross the x-axis, the points where they cross the x-axis. So, another name for zeros is root. So, we use root, and sometimes we use the word solution as well. When we're finding the solution of a polynomial function, we're really looking for their zeros. Okay, any questions there? A polynomial equation would have a y equals, I guess you could say, you know what, I probably should have done it this way. A polynomial function has, oh, actually, a y equals or an f of x. A polynomial equation that we usually think of would be something like this, where we set it equal to 0. Whenever you set it equal to 0, you're trying to find the solutions or the x-intercepts, and you set y, you replace y with 0. That's what we mean by a polynomial equation. Okay, so that's really key right there, you guys. When we're talking about solving a polynomial equation, that means you replace y with 0. Okay, we talked about a root being an x-intercept. Okay, imaginary numbers. How many of you guys remember what the pure imaginary number is? I. Okay, what does it represent? Yeah, some of you guys, I heard you say it. The square root of a -1 is we replace it. Some mathematician a long time ago decided they were going to call it I. So anytime you have something like the square root of -6, that can be written as the square root of -1 times the square root of 6. And the square root of -1 can be replaced with I, so your answer is I times the square root of 6. In other words, if you have a square root of a negative number, the answer to that, there's no answer to that in the real number system. So they had to come up with a different number system for imaginary numbers, for square roots of negative numbers. So they came up with the imaginary number system. Now, I know in the past, when I've taught about imaginary numbers, students sometimes get angry. Are you guys feeling anger feelings right now? None of you? That's like a first. And that's probably because you guys have already had it before. Okay, but I get some kids that start getting mad. Well, why are we learning about imaginary numbers if they don't exist? Well, they do exist. I just think some mathematician a long time ago came up with a bad name for it because they are actual numbers. They do exist. Just like 1, 2, 3, 4, 5, 6 exist. Imaginary numbers exist. They're just a different number system, and we had to have them to solve certain problems. Okay, in electronics, if it wasn't for imaginary numbers, we would not be able to solve some of the equations and solve problems involving electronics. Okay, and we have some of the technology we have today because of imaginary numbers. So imaginary numbers are numbers that actually exist, but we don't call them real numbers. Someone decided to call them imaginary numbers. They don't show up on a graph, and that's probably why they called them imaginary numbers. That's probably the reason they decided to call them that. Okay, complex numbers are all of the numbers in the real and imaginary number systems. So if I have complex numbers, that involves real numbers and imaginary numbers. And a complex number can be written in the form of a plus bi. You remember doing stuff like that? Okay, so a plus bi could be something like 2 plus 4i, or negative 6 minus 7i. Okay, but if you, since all complex numbers can be written as in terms of complex number, like if I just want a real number like 2, I could write it as 2, but if I want to put it as a complex number, I would write 2 plus 0i. Well, 0 times I is just 0, right? So I still have 2. And imaginary numbers can be written as 0 plus 4i. So if I just wanted the pure imaginary number 4i, I could have written it as 0 plus 4i in the complex number system. Okay? So pure imaginary numbers would be like 4i, negative 10i, 6i, and so forth. I times the square root of 5. Those are pure imaginary numbers. Okay? All right. Any questions on any of that stuff? Okay, I want you to go to page 206. And I want you guys in your groups to do example 2. Now, they give you the answer. I want you to try and do it before you look at it. So do it yourself first and then check your answer to see if you got it right. State the degree and leading coefficient of the polynomial. Determine whether for it is a 0. Oh, you know what? That was your bell work. Let's skip it. You guys already did that one. Okay? Just set it there on my keyboard. Yeah, right there in that stack. Okay, we're going to this one right here, the fundamental theorem of algebra. I want everybody to go to the top of page 207 and read what the fundamental theorem of algebra is. Okay, what is the fundamental theorem of algebra? What is it basically stating? Who thinks they can put it in their own words? It's actually pretty easy. What do you guys think at this table over here? Clayton, what do you guys think? What is the fundamental theorem of algebra? No, I want you to put it in your own words. What does that mean? Interpret it for us. Well, it's basically saying that if anybody else want to try? Who thinks they understand? Kyle. Yeah, that's what it's saying. The degree of a polynomial can determine how many zeros there are. Now, the fundamental theorem of algebra says anything of degree greater than 0 has at least one root, right? But the corollary, I want you guys to go down to corollary. That's what's important. Everybody write this down. It's basically saying this. If a polynomial has degree n, then it has n roots. That is what it is saying. Write that down, Montana. If a polynomial has degree n, then it has n roots. Let's substitute a number in there. Dakota, what's a number we can use for n? Okay. If a polynomial has degree 5, then it has 5 roots. If a polynomial has degree 3, then it has 3 roots. If a polynomial has degree 7, it has 7 roots. What is a root? It is that, but what else is it in math? Jacob? Say that louder, I can't. The polynomial? Yeah? So, like, what are the roots of, let's say, let's go 15. What are 2 roots of 15, you guys? 5 and 3, right? They're the numbers you multiply together to get 15. Is that what you're saying? Okay. So, 5 and 3 are roots, right? Now, I said earlier that a root is a 0, right? Or an x-intercept. But that's not true. Not all roots are going to be zeros. All zeros will be roots, but not all roots will be zeros, okay? So, basically, what this is saying is that if you have a polynomial of degree 3, then you can have up to 3 roots. Like if you had x minus 3, x plus 4, x minus 2, you have 3 linear factors right there. These are all linear because it's x to the first, x first, x first. That makes them linear, right? If I multiply those 3 linear factors together, what am I going to get? What's my highest degree term going to be? Say that again, Miranda. X to the third, right? If I multiply all these out, I'm going to get a polynomial that's going to say x to the third. Now, this thing's going to have exactly 3 roots. Now, you can see what they are right here. X equals 3, because 3 minus 3 would make 0. X equals negative 4, because negative 4 plus 4 would make 0. And x equals 2, because 2 minus 2 would make 0. Does that make sense? Now, sometimes, though, we might have something of degree 3 where you have one of them, or 2 of your roots are what? Imaginary roots, right? But what this is saying is if it's degree 3, it's going to have 3 roots for sure. Some of them might be imaginary. They might not show up on the graph. They might not cross the x-axis. But they're going to have 3 roots. That is what it's saying. Okay? Now, everybody go to example 3 on page 208. 208, page example 3. Oh, wait. Everybody look down at the bottom page 207. I want to look at that first. There's some graphs right there. Okay. Now, you guys see these pictures right here? Degree 1, degree 2, degree 3, degree 4? Those are showing the maximum number of real roots or real zeros it's going to have. So if you have a function of degree 1 like y equals 2x plus 4, that's degree 1. It's going to be a straight line. It's going to cross the graph one time, or the x-axis one time. Look at the one that's degree 2. It's going to be a parabola, right? We all know that quadratic makes a parabola. It can cross the graph up to 2 times. A cubic function can cross it 3 times. So degree 3 can cross 3 times. A degree 4 can cross it 4 times. A degree 5 can cross it 5 times. But do they have to? Like on degree 5, does it have to cross it 5 times? No. It could have some imaginary numbers. But guess what? Anything of odd degree is going to have to cross at least how many times? How many times is the least number of times something of degree odd? 1 time. Who said that? Okay, Dakota. Yeah, why is it that? Well, think about Klein. Yeah, the end behavior. It's got to go up one way and down the other. Exactly right, Klein. And so it's going to have to cross at least once. That means if it was degree 5 and it crossed only one time, what does that tell you about the other 4 roots? They're imaginary. So you can have, if you have degree 5 and it crosses and it has one real root, it has to have a total of 5 roots. We just learned that in the fundamental theorem of algebra, right? So 4 have to be what we call complex roots or imaginary roots. They use the word complex to describe the imaginary ones. I don't know why, but they do. Because complex really should describe all the roots, real and imaginary. But that's what you get. Okay, so you guys know that it has to cross at least once. Now, what about if it's even degree? Does it have to cross? What if I have an even degree function? Does it have to cross the x-axis? Why not? Yeah, an even function might do that right there, like Miranda's saying. It may never cross the x-axis. So if it was degree 4, what does that tell us about all the roots? They're all 4 imaginary. 4 complex roots, right? That's what the fundamental theorem of algebra tells us. Okay, now go to example 3, you guys. Write a polynomial equation of least degree with roots 2, 4i, and negative 4i. How are you going to do that? You guys, my solutions are these. So I want to write them as linear factors. So what are my linear factors, you guys? What are they? X minus 2, x minus 4i, x plus 4i. Now this is going to give me a polynomial. Okay, Clean and Montana, listen now. This is going to give me a polynomial of least degree that has these 3 factors. When it says least degree, we want the smallest degree. Well, if you're going to have 3 solutions, you got to have at least degree 3, right? So it's going to be degree 3. Notice that my factors are going to be opposite of the sign up here, because if I put 2 in here, 2 minus 2 would make 0, right? And that would make it. So it's always going to be opposite sign. Which of these 2 would you think you would multiply together first? Yeah. I don't know if you guys remembered, but this is something really important. Listen to this. You guys, imaginary roots always come in pairs. Got it? They come in what we call conjugate pairs. Imaginary roots always come in conjugate pairs. That means the signs are going to be opposite. X minus 4i, x plus 4i. X minus 3i, x plus 3i. X plus 5i, x minus 5i. They're always going to come in roots. The nice thing about that is when you multiply them together, the middle terms add up to 0. And the last 2 terms are going to be an I squared, which is going to become a positive number. So let me just show you right here. X times x is x squared. X times 4i is 4ix. Negative 4i times x is a negative 4ix. And negative 4i times positive 4i is a negative 16i squared. Now look at this. I want you to see. When you add 4ix and negative 4ix, what do you get? 0. These 2 middle ones add up to 0. Here's an even cooler thing. See this? Negative 16 I squared. What is I squared equal to? Do you guys remember in your imaginary numbers? It's equal to negative 1. Everybody write this down in your notes to remind you. You learned this last year. I squared equals a negative 1. So this is really saying negative 16 times negative 1. What is negative 16 times negative 1? It's a positive 16. So you guys, my answer is x squared plus 16. That is my answer. I mean, when I multiply those 2 together. Now I have to multiply x minus 2 times x squared plus 16 still, right? So I'm going to distribute the x, so I get x cubed. X times 16 is 16x. Negative 2 times x squared is negative 2x squared. Negative 2 times 16 is a negative 32. I write them in descending order. So my negative 2x squared would become second plus 16x minus 32, right? And right here, you guys, is my polynomial function of least degree. That would be a polynomial. That polynomial would cross the x-axis at 2, and then it would have two solutions that are imaginary. All right. Hey, we didn't quite get through all of this, but we got through most of it. I'm going to give you your assignment. I'm going to give you 2 class periods to work on this, but I would suggest you try and get the first part done. I suggest you try and get the parts that you know done now, okay?